Solving trigonometric equations in the form a cos theta plus b sin theta is equal to c. In the previous video, we go through case 1 and case 2 of the 3 cases that we can typically encounter in the exam. The first case being simple trig equations, the second being in the form of a quadratic, and the third and final case that we'll be focusing on in this video is in the form a cos theta plus b sin theta is equal to c. However, it is important to note that this is not the only form in which this type of equation can be presented. Other examples include a cos theta minus b sin theta, or a cos theta plus b cos theta, or any combination of sine and cosine. To be able to solve these types of equations, we need to be able to choose the appropriate compound angle formula. Please note that it is rare that tan is actually incorporated into this equation, so don't worry about tan. Given that the equation is in the form a cos theta plus b sin theta though, let's look at this example. To be able to solve this type of equation, we need to put this in the form of this. So r cos theta minus alpha, where r is greater than 0, and alpha is between either 0 degrees and 90 degrees, or 0 and pi over 2 radians. So in the case of degrees, this, and in the case of radians, this. And this is done using our compound angle formulae. In case you forgot, these are all our compound angle formulae. And please memorize all of them. And just to include some other forms so you can be a little familiar with them, these are just some other possibilities. Please don't memorize them. They could come in any forms, and just memorize the compound angle formulae instead. In the next part of the video, we are going to go through past papers in which I will show you step by step how we're going to solve these equations. Past papers. The first past paper that we're going to go through is 2021, and for 5 marks it states to express 4 sin theta plus 3 cos theta in the form of r sin theta plus alpha. Now, because we are given the form already, we don't need to choose the compound angle formula that we need to use. So we're going to start like this. The first step is we're going to equate the equation given to the form we're given. And notice that it is sine theta plus alpha. So we could expand that using the compound angle formula for sine a plus b. So in this case, theta would be a and alpha would be b. Okay? So here we do step 1, which is equate it. Then we're going to use the compound angle formula and expand it properly. Okay? And now that we have it in this form, we could rearrange it so it resembles the left-hand side. When it resembles the left-hand side, this becomes useful because then we can equate the coefficients. So you'll notice that sine theta and sine theta are here, and cos theta and cos theta are here. So if we rearrange it, meaning putting this behind and this comes closer here, we can look at that and say, oh, that looks similar, so we can equate them, right? So in this case of sine theta and sine theta, after rearranging it, we could easily see that r cos alpha is equal to 4 and r sine alpha is equal to 3. So we equate the coefficients and then we label them equation 1 and equation 2. These equations are important because we're going to use them to find alpha and r. So first we're going to find the value of alpha. And to do this, we have to manipulate the equations that we just made, equations 1 and 2. So we first divide equation 2 by equation 1 to find alpha. And we notice something pretty cool here. We know that tan alpha is equal to sine alpha over cos alpha. So you see how the identity was actually hidden right there, and we could use that to find alpha in general. So we replace it using the identity, and we could get tan alpha is equal to 3 over 4, and we get 0.64. So in the next part of the question, theta is asked for in radians, so also be very careful what is in degrees and what is in radians, right? So radians. Then we're gonna find the value of r. To do this, we're gonna square both the equations. So again, the equations come in useful. And when we do that, what we're gonna do is add both of them, okay? After adding the left hand side to the left hand side and the right hand side to the right hand side, we could easily solve for r. So we get r squared is equal to 25, and therefore r is equal to 5. So also recall that r is greater than 0, therefore r cannot be minus 5, okay? So therefore we only have one value, which is r is equal to 5. So now we can put it in our form. 4 sine theta plus 3 cos theta is equal to 5 sine theta plus 0.64. So this was r, and this is alpha. Okay, now part 2 of 2021 says for 5 marks to solve the equation, okay? Now, what we're gonna do is use what we found in part 1. So from part 1 that we just solved, we know that it is equivalent to 5 sine theta plus 0.64. Therefore, we can substitute it into the given equation. So what that means is we just equate it to 2, okay? So now we divide throughout by 5 to get rid of this, right? Then we end up with this equal to 2 over 5. Now we have an equation that resembles sine x is equal to k. So we could apply our general solution, okay? So a general solution for sine is theta is equal to n pi plus minus 1 to the power of n alpha, okay? So we find alpha and we just basically put it in our general solution. And also remember that we are treating this as one angle, okay? To find the specific value of theta given the general solution, we need to substitute different values of n. Always remember that. So always go back to my previous videos. Very, very important to learn this. So for this question, we need to find the value of theta that satisfies the constraints given in the question above here. Okay, so what we're doing now is we substitute in values of n. So n is equal to 0, n is equal to 1, n is equal to 2. And then we're going to see, okay, does this fit? No. So we don't use that. Does this fit? Yes. And does this fit? Yes. Therefore, theta is going to be equal to 2.09 or 6.04, okay, given these constraints. So it's very, very important to keep that in mind, the constraints, because they will not take it if you put an answer out of the constraints, okay? You'll probably lose a mark. So that's how you do 2021. 2019 tells us that we need to let f of x equal to cos x plus 2 sine x. Then it asks us to express f in the form r sine x plus alpha, where alpha is an acute angle. So we first need to ask ourselves, what do we need to find? We need to find r and alpha. So in this question, we are asked to put the given equation into this form. Okay, so we are already given the form, and therefore we don't need to choose which compound angle formula to use. So we got lucky again. Similar to the previous one, we first start by letting the equation equal to the form given. Okay, now to find r and alpha, we're going to do the following steps. The first thing that we're going to do is expand r sine x plus alpha using the compound angle formula for sine a plus b. So sine a plus b, in this case, x would be a and alpha would be b. So we're gonna have this in the end and then multiply r by this and this, expand it properly. And now we have a form in which we can rearrange for it to resemble the left-hand side. Why are we rearranging it? Just because it's easier on the eyes. You could definitely go from this step to this step, but I recommend, just for ease of when you're looking back over to see if you made a mistake, just do this so you can be able to check properly. Okay? So what I mean by rearranging is noticing that cos x is here, that cos x is here, and cos x is here, as well as sine x and sine x. So we basically putting the cos x on the outside and the sine x on the outside to see that these coefficients can actually be equated. So the coefficient of cos x is 1 here, and on the right hand side it is r sine alpha. Therefore, we can say that r sine alpha is equal to 1. And the same goes for sine x. The coefficient of sine x is r cos alpha, and on the left-hand side it is 2. So we can equate them as well. By equating these two, we can see that we have two equations, okay? After equating the coefficients, we made two equations. And these are going to be super useful because what we're going to do is find the value of alpha as well as the value of r with these two equations. So the entire thing, we found these two equations, so just make sure they're correct, okay? So we find the value of alpha by manipulating the two equations above. We're going to divide equation 2 by equation 1, and we see the same thing. Sine alpha over cos alpha, what do we know? That it is equal to tan. So we're using that identity, and we're equating it to a half. So we're finding this right here, and we obviously plugging this into a calculator unless you're just brilliant. I'm just kidding. You know, we could know these things. I don't know if a lot of people had to memorize it back in school, but I was told to. And yeah, we get 0.46. So step 5 now, after we found alpha, we have to find r. So step 5 is all about finding r and using the same two equations that we found above. All right. To do this, we're going to square both the equations. So the first equation we square in here, and the second one here. So what we're doing is we equating it to 2 squared, and we get 4. This one will be 1 squared, which is equal to 1. And we're going to add both equations. To be able to add both equations, all you do is add the left-hand side to the left-hand side, and the right-hand side to the right-hand side, and we'll get this, okay? So we're going to solve for r, so we're going to factor it out, and this will be simplified to 5, and we'll get r squared. And look at this now. Because we factored it out, we could easily see an identity. We know that sine squared theta plus cos squared theta is equal to 1. So we'll have r squared multiplied by 1 is equal to 5. And we know that r is equal to the square root of 5. So therefore, we can say that our final answer is cos x plus 2 sine x is equal to the square root of 5, which is r. And as we found above, alpha would be equal to 0.46. Okay, so that would be part 1 of 2019. Part 2 states, hence or otherwise, find the general solution of cos x plus 2 sine x. So what we're going to do is use the previous part of knowing this, and we're going to put it here. So we're just substituting it, okay? So we're given that is equal to 0, so we're substituting it and we're putting it equal to 0. To get rid of the root 5, we're just going to divide throughout by root 5, okay? And this would still remain 0. And now it resembles sine x is equal to k. So the general solution for sine is as such. Okay? So is as such, and then we could solve for alpha. So we know that alpha in this case would be equal to 0. So we plug it in. And we already know, remember that we're treating this as 1. Okay? And we could just put it all the way on this side now. And say that x is equal to n pi minus 0.46. And that would be the solution. 2019 part 3 asks us to determine the minimum value of 2 over 2 minus f. And this is for 3 marks. F in this case, from the previous parts, we know is cos x plus 2 sine x. And what we also know is that we found cos x plus 2 sine x would be equal to square root of 5 sine x plus 0.46. So we can directly equate f to this, in which we do here. So the equation asks us to find the minimum value of 2 over 2 minus f. Therefore, we need to substitute the max value of f, seeing that is on the denominator. So let's look at this example here. A half and a third. Which one is the bigger fraction? A half. So even though this is a smaller number, it is the bigger fraction. Okay? So the larger the number actually gets on the denominator, the smaller the fraction is. So it goes like a half, a third, a quarter. It gets smaller in this direction as this number here rises. Okay, so that as that increases, the fraction gets smaller. So because it's on the denominator, we're going to find the maximum value, and well, we substitute in it, okay? So from the graph of y equal to sine x, y sine x, because we have sine x in the equation, okay, we know that the max value of sine x here is 1. Okay, so we're going to basically substitute f to find the maximum value of f. Okay, so we can say that sine x plus 0.46 is equal to 1, and the max value, looking at this here, we just substitute in 1. So we have this. So I hope you all know that the square root of 5 multiplied by 1 is equal to the root 5. So now we substitute in the max value of f into this, and therefore the minimum value is equal to 2 over 2 minus square root of 5. Use your calculator or your very brilliant brain and come to this conclusion that the minimum value is equal to minus 8.47. 2016 for 5 marks says to express the function f theta is equal to sine theta plus cos theta in the form r sine theta plus alpha, where r is greater than 0 and theta is between 0 and pi over 2. When we see pi over 2, we know that we need to use radians. Okay, all of this is for 5 marks. Let's begin. The solution goes as such. The step 1 is to let this equal to the form given. Okay, again, we don't need to choose because it's already given to us. So again, we got lucky. Step 2, we expand using the compound angle formula. We need to choose the right one. This is sine, so we're going to use the one for sine, A plus B. In this case, A is theta, and B is going to be alpha. When we do that, we're going to expand it. So this multiplied by this by this to get this equation here. When we do that, we need to recognize that there is a sine theta here, a sine theta here, as well as cos theta and cos theta. So we rearrange the right hand side to resemble the left hand side to be able to equate the coefficients of sine and cosine. When we do this, we create these two very simple equations that we're going to be able to use to find what we need in the future. So to find the value of alpha, we are going to use these two equations. We're going to divide equation 1 by 2. Why equation 1 by 2? Because sine alpha over cos alpha is equal to tan alpha. And then we can use that identity to say tan alpha is equal to 1, and therefore find alpha is equal to pi over 4. Then we're going to find the value of r. To do this, we're going to square both the equations. We square in the first one here, the second one here, and then we're going to add both the equations. To do that, we add the left-hand side to the left-hand side and the right-hand side to the right-hand side. Then we're going to simplify it. So in the end, we're going to have r squared sine squared alpha plus r squared plus cos squared alpha is equal to 1 plus 1. 1 plus 1 is, everybody knows, window. I just kidding. 1 plus 1 is 2, right? So using the identity sine squared alpha plus cos squared alpha is equal to 1, we're going to substitute it and get r squared is equal to 2, and therefore r is equal to the square root of 2. So we can easily say that cos theta plus sine theta is equal to square root of 2, which was r, sine theta plus pi over 4, which we found before to be equal to alpha. Part 2 of 2016 says to find the maximum value of f and the smallest non-negative value of theta at which it occurs. And this is all for 5 marks, so a lot of marks there. The solution is as such. We know that from part 1 that f theta is equal to sine theta plus cos theta. And we also found in part 1 that this is equal to square root of 2 sine theta plus pi over 4. So we can say that the f that they're referring to here is what we found here. Now we're going to look at the graph of y is equal to sine x and know that we want to find the maximum value. Okay, so we look at the greatest point on the graph and see that it's equal to 1. Therefore, the maximum value is equal to 1. So we can say that sine theta plus pi over 4 is equal to 1. We're going to substitute it into this equation here and say that at the maximum value of f theta is equal to square root of 2 multiplied by 1 because we found the max value, and then it's equal to 2. Therefore, f theta is equal to 2 when sine theta plus pi over 4 is equal to 1. So now we're going to look at this section and we're going to say that pi over 4 plus theta is equal to sine inverse of 1. We know that the sine inverse of 1 is equal to pi over 2. So now all we need to do is say that theta is equal to pi over 2 minus pi over 4, and we know that that is pi over 4. So therefore the smallest non-negative value of theta is equal to pi over 4, and that's the solution for that part. Now you and I are going to attempt to solve 2017 together. But before we do that, I highly recommend that you practice on your own before, so please pause the video and practice because, as we all know, practice does make perfect. So now we're going to do it together. So you can unpause the video now. So 2017 states to express f theta, which is 6 cos theta plus 8 sin theta, in the form r sin theta plus alpha, where alpha is between 0 and 90 degrees. Notice this is degrees and not radians, so keep your calculator in degrees when we solve in this question. The first thing that we're going to do is let f theta equal to r sin theta plus alpha. So we let in f theta equal to the form that they want us to put it in, and in this case it is r sin theta plus alpha. So we know that f theta is 6 cos theta plus 8 sin theta, and that would be equal to r sin theta plus alpha. Now, what do we know? We could see that on the right hand side we have sine theta plus alpha, and what do we have here? We could use the compound angle formula for that. So let's do that. First of all, let's recall the compound angle formula for sine A plus B. Alright, so now let's expand it. In this case, theta would be A and alpha would be in the place of B. So let's do that now. And now we're going to multiply r by this side and this side. So we just expanded it a little more. What we're going to focus on is making the left-hand side and the right-hand side look like each other. So making them resemble. So we have a cos theta and a cos theta, as well as a sin theta and a sin theta. So let's do that now. So we can see that the coefficient of cos theta would be 6 here on the left-hand side, and on the right-hand side, it would be r sin theta. Sorry, r sin alpha. Okay, so let's do that. So all we did there was equate the coefficients from the right and left-hand side because it has the same term attached to it, okay? So that's how we could do that. So we have to do the same thing for sine. In this case, for sine, we have 8 equal to r cos alpha. And now we can label them equation 1 and 2. These equations are important because we are going to use these, manipulate them to find r and alpha. But first, we're going to find alpha. So to find alpha, what we're going to do is divide these equations by each other. So in this case, we'll divide equation 1 by equation 2. And why did we do that? We did that because if we divide equation 1 by equation 2, you can see that we get in an identity, and that's the entire point of using this. So the identity in this case, we know that tan theta is equal to well, we could say theta is equal to sine theta over cos theta, but in this case, it would be alpha. So 6 over 8 would be tan alpha. And from here, we could easily solve for alpha. So plug this in your calculator really quickly, and you should get 36.9 degrees. So remember, the constraints for alpha were given in degrees. Therefore, we must work in degrees. Okay? And we're going to manipulate the same two equations again to find what? Exactly, r. So in this case, we're going to square them. All right, so the first one, all squared is equal to 6 squared. So that would give us r squared. Sine squared alpha is equal to, we know that 6 squared is 36. And the second one, r cos alpha, all squared is equal to 8 squared. I don't know why I keep saying theta and alpha interchangeably. Don't make that mistake, please. That's my bad. So r squared cos squared alpha is equal to, and 8 multiplied by 8 is 64. Okay? Now, what we're going to do is add both these equations. So we add in this and this. The reason we're doing that is because there's also a hidden identity. So to add equations, first of all we do is add the left-hand side to the left-hand side and the right-hand side to the right-hand side. So let's do that. What do we have that's common between this? Well, I'd say for now. But what we have common is the r squared, so we could pull it out. So we know that this identity here, sine squared alpha plus cos squared alpha is equal to 1. So this we'll have r squared, 1 is equal to 36 plus 64, which we all know to be 100. So in this case, we could say that r is equal to 10, because r would be equal to the square root of 100. So after applying the identity here, we can say that it was 1, again, just in case anyone missed it, and then r would be equal to 10. So now we have alpha and r. We could just plug it into the form that they originally wanted and say that is equal to 10, which is r sine theta plus alpha, and alpha we found to be 36.9 degrees. Therefore, this is our final answer. Now I would like you all to pause the video again here and attempt to solve part 2 of 2017. Here is the written solution, which you all should want to know how to solve and should know how to solve, because it could follow a question like we just did, which was 2017 part 1. So please do also learn how to solve this question.